In this recurrence relation, we are given 1 plus un times un plus 1 is equal to 1 minus un. Looks a little bit confusing, but it's really simple enough, these questions. We're told u1 is equal to a half, and we're asked to find sum of, so immediately you're thinking Sn is equal to a times 1 minus the ratio to the power of n, all over 1 minus the ratio. So let's have a look at this sequence. u1 is equal to a half. So if we let n equal 1, we get 1 plus u1 times u2 is equal to 1 minus u1. Just keep it nice and simple. We're looking for u2 on its own, so we'll divide by 1 plus u1 to get u2 is equal to 1 minus u1 over 1 plus u1. And given that u1 is equal to a half, we have 1 minus a half on top and 1 plus a half on the bottom. So this is going to give 1 over 2. Your calculator will just do it for you from here if you don't want to have to do it manually. 1 over 2 divided by 3 over 2. If the denominators are the same, they cancel. So this is going to be equal to 1 over 3. Then if we allow n equal to 2, we get u3. We get 1 plus u2 times un plus 1, which will be u3, is equal to 1 minus u2, or u3 is equal to 1 minus u2 over 1 plus u2. So this is going to be equal to 1 minus u2 is a third, divided by 1 plus u2, which is 1 plus a third. So we're going to get 2 thirds divided by 4 thirds. Again, denominators cancel, and we get 2 over 4, which is 1 over 2. Now it looks like the sequence is going to be a half, 1 over 3, 1 over 2. Does it go back to 1 over 3? Rather than assuming, I think you should always just double check. So we're kind of predicting this is going to be a third again, based on what we've seen so far. So we're going to get, when n is equal to 3, we get 1 plus, and just double check here, 1 plus un, so I'll just leave it visible at the top, 1 plus u3. You could just write immediately that u4, this one, u4 is going to be equal to 1 minus u3 over 1 plus u3. So maybe just cancel this one, bring it over here, 1 plus u3. So we're going to get 1 minus u3, which is a half. So we are back definitely to our same sequence over 1 plus a half, which we've seen up here, is equal to a third. It's the same sum. So our sequence is 1 over 2, 1 over 3, 1 over 2, 1 over 3. And we're asked to find the sum of the first 24. So 12 of them will be a half, and 12 of them will be a third. 12 times a half is 6. 12 times a third is 4. The sum of the first 24, maybe we should write S24, is equal to 6 plus 4, which is equal to 10. Question 9, we have this recurrence relation. un plus 1 is equal to un plus 2 over un plus 1. We're given two values here. u0 is 1, and actually just give them one value and then find u3 as a fraction. So to get u1, we're told it, u0 is 1, so let's let n equal to 1, or n is equal to 0 actually. We let n equal 0 to get u1. u1, with this being 0, is going to be equal to n is 0, so this is 0, u0 plus 2, over, again, u0 plus 1, and u0 is 1 here, so we're going to get 1 plus 2 on top, which is 3, and 1 plus 1 on the bottom, which is 2. Now we're going to let n equal to 1. We're asked to find u3 as a fraction. N equal to 1 will give us u2. So it's going to be equal to, changing n to 1, it's going to be u1 plus 2 over u1 plus 1. Again, calculator use if you want. 3 over 2 plus 2 divided by 3 over 2 plus 1. So this is going to be 3 over 2 plus 2 is going to give 3.5, 7 over 2. And on the bottom, it's going to be 3 over 2 plus 2 over 2, 5 over 2. Same denominators to give us 7 over 5. And then to get u3, we have to let n equal 2. This will give us u3. That is a 3 is equal to u2 plus 2 over u2 plus 1. So 7 over 5 plus 2, which is 10 over 5, divided by 7 over 5 plus 1, which is 5 over 5. So we're going to get 17 over 5 divided by 12 over 5. Same denominators, so we're going to get 17 over 12 for u3 as a fraction.